In this video, we're going to look at balancing oxidation-reduction reactions. And there's two common ways to do it. One is using the oxidation number method, and the other is using a half reaction method. And I'm only going to cover the half reaction method because that's the one that we're going to use here in this chapter. So balancing oxidation-reduction reactions. And again, we're going to use the half reaction method, which I honestly think is the easier of the two ways anyway. It's always my preferred way to do it. So our half reaction method. In both methods, the half reaction and the oxidation number method, we do want to remember when we're balancing oxidation reduction reactions, we're not just balancing atoms, right? We still can't, break the law of mass conservation. I can't have two carbons on one side and one on the other, right? I have to balance atoms, but we also need to balance charge and electrons. If something is going to lose 3 electrons, something has to gain 3 electrons. So the number of electrons lost has to equal the number of electrons gained. So we need to balance atoms, and we need to balance charge. So if one side has a +1 charge, the other side also has to have a net charge of +1. So the net charge on both the reactant and product side of our equation has to be the same. And that's always been true. Everything's usually neutral, but our charge does need to be balanced as well as our atoms. And essentially, the number of electrons lost must equal the number of electrons gained. So again, balance atoms, balance charge, balance your number of electrons. The easiest way is to just go through an example. So I'm going to give us an unbalanced equation. So I have dichromate ions plus chloride ions going to chromium 3+ plus chlorine, so diatomic chlorine. And I'm just going to remove these states of matter just because it's going to get kind of messy and we don't really necessarily need them so much. So obviously not balanced, right? I have 7 oxygens here. I have no oxygen on my product side. 2 chlorine, 1 chlorine, 1 chromium, 2 chromium, total mess, right? Not at all balanced. And you can balance chemical equations in either acidic or basic solution. We're going to balance this one in acidic solution. And we'll do one of each. But if it's in acidic solution, what that means for us is we can add protons and water wherever we want. Looking at this reaction, right, that's how we're going to balance that oxygen. Right here I have 7 oxygen, here I don't have any, but I know that water contains oxygen and I can add water wherever I want. So we're going to end up with probably 7 water on that product side. So again, we're doing this one in acidic solution, which means we can add protons in water. First thing we're going to do is we're going to split the reaction into 2 half reactions. One of the half reactions is going to be the oxidation, the other is going to be the reduction. So our oxidation and reduction half reactions. We're going to assign oxidation numbers here. Sometimes you need the oxidation numbers to do this. Sometimes you don't. We're going to balance the 2 half reactions separately and then add them together. The only way to do that is to keep like atoms together. So basically the one that contains chromium is going to go to the one that contains chromium. That's going to be 1 half reaction. And then the chlorine going to chlorine is going to be the other half reaction. I do want us to be able to assign oxidation numbers though, and we also need to be able to recognize which is the oxidation and which is the reduction. So for practice, let's assign oxidation numbers to this. And I would really love you to do this on your own. So hit pause, assign oxidation number to each atom in the reaction above using the rules from the last video, and then when you're ready to go through it, hit play. All right, hopefully you did that. So Cr2O7, 2 minus, oxygen has a -2, right? It's not an epoxide, it's not bonded to fluorine. I happen to have 7 of those, however, so -2 times 7 gives me a -14 total. I know when I add the total for chromium to the total for oxygen, it has to add to a -2. So I know that chromium has to be a +12 total, right? There's 2 of them, and I know that when I add the 2 together, it has to be a +12, right? Because a +12 and a -14 is a -2. Since I have 2 chromium, +12 divided by 2 is a +6. Again, be really careful. If I ask for the oxidation number on an atom, remember you're giving me the oxidation number on that atom, not the total, right? The oxidation number on oxygen is -2. It's not -14. It's -2. I just happen to have 7 of those, so the total is a -14. Right? The oxidation number on chromium is +6, not +12. It's +6. I happen to have 2 of them though, so the total is +12. Chlorine here, a little bit easier, monoatomic ion, another monoatomic ion, and then diatomic chlorine is its elemental form, so 0. And then again, I'm going to look to see how it's changing. So I have chromium going from +6 to +3. That's going to be my reduction. So my reduction half reaction. And I'm going to rewrite it here, but I'm going to leave a little bit of space between reduction and my half reaction. Right, so chromium is going from +6 to a +3, it gained electrons. And then my oxidation are going to be my chlorines, right? It's going from -1 to 0, became more positive, it lost electrons. So Cl minus going to Cl2. And I like to write these, we're eventually going to add them back together, and it's easier for me if I keep my arrows lined up so they're right on top of each other. That way when I add stuff together, I know that everything over here is going to be on the reactant side and everything over here is going to be on the product side. It's just easier for me to see it. So I like to line those up. So our next step is we're going to balance all atoms except oxygen and hydrogen. And I'm just going to write the rules here. I'm going to keep writing them as we go, but then I'm just going to go back up to this part and do that. So I have 2 chromium here. I only have 1 chromium here. So I'm going to add a 2 to give me 2 chromiums. I'm not going to worry about the oxygen yet, right? Because it said except oxygen and hydrogen. So I'm not worried about that. Here I have 2 chlorine. Here I only have 1 chlorine. So I'm going to put a 2 in front of chlorine. Remember, when we're balancing atoms, we can put coefficients in front of them, right? We can never change our subscripts. I can't go and do this to get 2 of them. That would be incorrect. The only thing I can do is I can add these coefficients. Oops. So I can put a 2 here to balance it. So everything's balanced except for oxygen and hydrogen if we had it. My next step is we're going to balance oxygen and hydrogen by adding H plus and or water. It doesn't always have to be both. Often it is, but it doesn't have to be if acidic. And then if it's basic, which this one isn't because I already said acidic, but if it was, we would add hydroxide ions and water, or water. So this one we're doing an acidic solution, so we can add hydrogen and water wherever we want. So on my first half reaction, I have 7 oxygen here. So in order to get 7 oxygen, I have to go add 7 water, right? I now have 7 oxygen on my product side. I also happen to have 14 hydrogen, so now I have to go back and add 14 protons to that side, right? So I have 14 hydrogen, 7 times 2 is 14 hydrogen, 2 chromium, 2 chromium, 7 oxygen, 7 oxygen. This one, I don't have to add anything because it's already balanced, right? I don't have oxygen or hydrogen, so I'm not worried about it. My next step is we're going to actually balance charge. And we're going to do that by adding electrons. It's going to look kind of weird at first. We're actually going to put plus E with a little negative sign on whatever side we have to balance our charge. Once we add them back together, those electrons are going to cancel each other out. So I'm going to do the second half reaction first. If I look at this reactant side, right, each chlorine has a -1. I happen to have 2 of those. So my net charge over here right now is a -2, right? That would be my net charge. If I look over here, I have no charge. Electrons are negative, so to balance my charge, I have to go and add 2 electrons to this side, right? Now I have a net charge of -2. So I have a -2 on both sides. My charge is balanced, right? Remember, if we go back up, we said one of the things we had to do was balance charge. We've already balanced our atoms. Now we're working on the charge. So going up to my first half reaction, and sometimes I end up counting these wrong at first, but here I have 14 positive charges, right? Each proton has a +1. I have 14 of them, so that's 14 positives. Here I have a -2. So on this side, I have a +12 total, right? That would be my charge. If I go over to this side, this is a +3. I have 2 of them, so that gives me a +6. This has no charge, so +6 total. So to get those charges to be equal, I actually have to go over to my reactant side and add 6 electrons. Right? When I add those 6 electrons, this now becomes +6. So my net charge is balanced. Next up, we're going to make the electron count the same for both half reactions. By multiplying by a coefficient. And actually, I'm going to add to this, this is important, by multiplying the entire half reaction. You're not just going to multiply the electron count, but you have to multiply the entire half reaction. If you only multiply the electrons by a coefficient, your charge is no longer balanced. So by multiplying the entire half reaction by a coefficient, right, by some factor. Let's actually just say factor. Multiple, I don't know, whatever the better way to say is. So if I go back up, here I have 2 electrons, here I have 6. To make those two numbers equal, I need to multiply this entire thing by 3, right? 2 times 3 gives me 6, so I have 6 on both of them. But if I just multiply this by 6, I'm going to have, sorry, if I only multiply this by 3, I'm going to have a negative 6 on this side for charge. I'm still only going to have a minus 2 over here, and my charge is no longer going to be balanced. So you can't just multiply this by 3, you have to multiply the entire half reaction, right? The entire half reaction by 3. So we need to multiply by 3. So this is going to become a 6, right? 2 times 3 is 6. 1 times 3 is 3. 2 times 3 is 6. So the electron count on both half reactions is the same, right? I have 6 electrons each. This is, I guess, the second place to really check. Your electron count on the two half reactions, or I should say the placement of those electrons, should be opposite, right? For the reduction, and I should have said this earlier, but my reduction, remember you're gaining electrons, so your electrons are a reactant, we're adding it to it, right? My electrons are over here on this side, it's something I'm adding in, right? It's gaining electrons. My oxidation is losing electrons. My electrons are always going to be on the product side, right? It's something I'm producing. So always check that. If you end up with your electrons on both sides, right? If it's on the reactant side for both half reactions or on the product side for both half reactions, you goofed up somewhere. They can't both gain them. They can't both lose them, right? One has to gain, the other has to lose. So they should be on opposite sides when you add those electrons. So in this step here, balancing the charge by adding electrons, and you might even want to write this down, they should be on opposite sides for the two half reactions. And then when we add them together, we're actually going to cancel them. Right here, our electrons are reactants, right? We're gaining them, right? We're adding them in. Here we're losing them, we're giving them off. Our electrons are products. So those should always be on opposite sides. Next step, and this is our last step, is we're going to add them together. So I'm going to hopefully fit this in here somewhere. So we've added reactions together before, right? Everything on the reactant side gets totaled, everything on the product side gets totaled, and then anything that's the same on the reactant and product side gets canceled. Our electrons should always get canceled. If they do not get canceled out, you goofed up somewhere, right? They're supposed to be on opposite sides. They're supposed to have the same number, so they're always going to get canceled out. So these 6 electrons are going to cancel these 6 electrons. And then be careful, sometimes you might have other things like hydrogen and water that cancel. This time this is all I have, so now I'm just going to rewrite what's left. I have 14 protons plus Cr2O7 minus plus 6, don't forget that 6 chloride ions. And the order that I write these in doesn't matter. It doesn't matter if I put the chromium ions first and then the chlorine, or if I put the chlorine first and then the chromium. If I want to put the water in the middle, it doesn't matter as long as that all the reactants are on the reactant side and all of the products are on the product side. So this here, and I would double check it. There's a lot of steps. So when I say double check, we're going back up and we're checking for these. Do my atoms balance? Does my charge balance? So let's just check real quickly. I have 14 hydrogen, 7 times 2 gives me 14 hydrogen. 2 chromium, 7 oxygen, 6 chlorine, 3 times 2 gives me 6 chlorine. So atoms are good. And then charge, I'm kind of running out of room here, but I have 14 positives, a -2, and then another -6. So 14 positives and 8 negatives gives me 6+. And then if I go over to this other side, I have 2 things that have a 3+ charge, no charge, no charge. So 6+, my charge is balanced, so good. So I want to do another example, but this time we'll balance it in basic solution. So let's have manganese 2+ plus chloride ion, ClO3-, going to MnO2 solid plus chlorine dioxide. And we're going to do this in basic solution. So I'm not going to write down all the steps. We can scroll back up and look at them. But the first thing we're going to do is we're going to split them into 2 half reactions. One is going to be my oxidation and one is going to be my reduction. Again, we have to balance the separate ones. So this going to this is going to be one of my half reactions. This to this is my other half reaction. I do want us to assign oxidation numbers though for practice. So if you want to do this on your own, that would be a really great idea. So hit pause. And then when you're ready, come back. Alrighty, hopefully you did that. I always like a good monoatomic ion because they're pretty easy. Here, oxygen is going to be a -2, right? It's not in a peroxide, it's not bonded to fluorine. There happens to be 3 of them, so that's a -6 total. I know that when I add chlorine to it, it has to sum to a -1. So chlorine, in this case, is going to be a +5. Right? I have a +5, I have a -6 total. Right? -2 for each oxygen. There's 3 of them, so that gives me a -6 total. Add these together, I get that -1. Oxygen again, -2, not in a peroxide or bonded to fluorine, which means manganese is going to be a +4. Right? 2 oxygens at a -2 each gives me a -2. Has to sum to 0, so +4. -2 again. So chlorine is going to be a +4, right? -2 times 2 gives me a -4, so I need a +4 for chlorine. There's no charge on that, so it sums to 0. So my 2 half reactions, manganese 2+, going to MnO2, and this one is my oxidation half reaction, right? I'm going from +2 to a +4. So this is my oxidation. My second half reaction, ClO3- going to ClO2. And if I look at those oxidation numbers, +5 to a -4, my oxidation number is getting smaller, right? This is my reduction. And actually, let's take a look at this. I didn't do this on the last one. But remember we said that our number of electrons gained has to equal those that are lost. So manganese here, right? I'm going from +2 to +4. So we actually lost 2 electrons. Here, I'm going from +5 to a +4, which means we gained 1 electron. So again, this is not balanced, right? It's not balanced for a lot of reasons. Oxygen, here I have 4 of them. Here I only have 3, but my number of electrons lost does not equal the number of electrons gained, and that needs to be if it's going to be balanced. So totally unbalanced at this point. Okay, now that we have our 2 half reactions, our next step is to balance all of the atoms other than oxygen or hydrogen, and they are, right? 1 manganese, 1 manganese, 1 chlorine, 1 chlorine. Next step is to balance oxygen and hydrogen. And because we're in basic solution, we're going to add hydroxide ions and water. And this is often a little bit more difficult than acidic solutions, because with acidic solutions, you can balance the oxygen by adding water and then balance the hydrogen by adding protons. Here, you add oxygen in both of these, right? When I add this, I'm going to add oxygen. When I add this, I'm going to add oxygen. So if I look at like this one, like where do I even start, right? If I put water over here, I'm adding oxygen. If I put hydroxide over here, I'm adding oxygen. So kind of a general rule, go to the side that you're short oxygen on, and then add twice the amount of hydroxide. So again, I have 2 oxygen here, right? I don't have any oxygen here. So I'm short on the reactant side. I'm short by 2. So I'm going to add 4 hydroxide. And then I'm going to go to the other side, and I'm going to add half that amount of water. So half of 4 is 2. I'm going to add 2 water. And then let's check that. So 4 oxygen, 2 times, plus 2, sorry, is 4 oxygen. 4 hydrogen, 2 times 2 is 4 hydrogen. So looking at this one, again, I'm going to go to the side that I'm short oxygen on. So here I have 3, here I have 2, so this time I'm short on the product side. I'm short by 1, so I'm going to add twice that amount, which is 2 hydroxide. Go to the other side and add half that amount of water, so just 1 water. And we'll double check. 2 hydrogen, 2 hydrogen. 1 plus 3 is 4 oxygen. 2 plus 2 is 4 oxygen. Our next step then is to balance our charge by adding electrons. So looking at my first one, right, I have a -2 net charge on that side, right? I have a +2. I have 4 hydroxides with a -1 each. So a -4 and a +2 gives me a -2 total on that side. Here, I don't have any charge, so 0. To get those charges equal, I'm going to add 2 electrons to my product side. I now have a -2 net charge on both sides of that reaction. And this makes sense, right? If I'm being oxidized, I'm losing electrons. Electrons are something I'm giving off, right? It's a product, and they're on the product side. Looking at this next one, here I have no charge. Here I have a -1. So -1 total. No charge. I have 2 -1s. So that gives me a -2. To get the charge equal, I'm going to add 1 electron over here, right? I now have a -1 and another -1, which gives me a -2. So it is the same net charge on both sides of that equation. It is a reactant, sorry. Electrons are something I'm adding, right? If it's being reduced, it's gaining electrons, so that makes sense. My electron count is on opposite sides of my 2 half reactions, so we're feeling pretty confident. Next step is to multiply an entire half reaction by some coefficient, by some multiple, to get my electron counts equal, right? Here I have 2 electrons, here I only have 1. It needs to be the same, right? If I'm going to lose 2 electrons, I have to gain 2 electrons. So this entire half reaction needs to be multiplied by 2. So 2 electrons, 2 water, 2 chloride ions, 2 chlorine dioxide, and then 4 hydroxide, right? Everything gets multiplied by 2. And then my last step is to add these together. And if it's easier for you to just add first and then cancel after you add them, by all means do it. That way, I like to cancel them first, but you don't have to. So here I have 2 electrons, here I have 2 electrons, so they're going to cancel. And then this time I actually have water and hydroxide ions canceling also. 4 hydroxide and 4 hydroxide. Sometimes you'll have like 4 on one half reaction and 2 on the other, and then 2 of them will cancel. It doesn't always have to be the entire thing. In this case it is. Same with water, 2 waters and 2 waters, so those go away. And then just whatever's left. And then I would always double check this for both atoms and charge. So 1 manganese, 1 manganese, 2 chlorine, 2 chlorine, 3 oxygen times 2, is 6 oxygen. And then 2 times 2 is 4, plus 2 more is 6 oxygen. So my atoms balance, and then net charge, here I have a +2, and 2 -1s, so that's 0 total over here. And then no charge and no charge, so 0 also over here. So this would be my balanced equation.